So, I'd like to talk about Einstein's theory of relativity. Sorry, my name is Lekwa Gabriel, and Happy New Year. And this is a new channel. I'd love to welcome everyone that is joining this channel today to my channel, and I'd love to tell you that this channel is going to contain a lot of useful, um, concepts, and it's actually a channel that has been in my mind for a while now because I love physics, I love astrophysics, and I love the multiverse. And I actually want to share what I know with the world. And okay, I just feel like I have a lot to share that is very useful to my generation. So this channel we are focusing on the multiverse, the universe, science, and technology. So I just want to say, first of all, I would love to start off on time and Einstein's theory of relativity. Now, I'm not here to criticize any scientific theory or criticize any because in truth, most of the works done are okay. I just want to add to it. Now, I want to adding to Einstein's theory of relativity. Um, I'd love to add something because it says that time is relative to the observer. Now, I just want to say time is not just relative to the observer. And I'm going to give examples. Why is time not relative? This could actually be the key to us understanding the universe, I believe. Why is time not relative to the observer? Because time is relative to the observer, yes. In addition to it, not why, in addition to it, time is also relative to the environment of mass of the universe. Because time in space is different from time on earth. Let's use these two examples. I have two balls of light with me. One ball, one ball has more mass. So it will take about one ball has more mass. So it takes about it takes about 1 hour, 2 hours to for that ball to reach 100 degrees Celsius because it's a ball of light. And I have another ball on my left hand. It takes about 1 minute for it to reach 100 degree Celsius. And now it's not just that the ball has more mass, it's because the metabolism of the two balls inside the balls is the structure inside is entirely different. It is not based on mass. Sorry, it's not based on mass. So if it takes one ball about 2 hours to reach 100 degrees Celsius, and it takes another ball about 1 minute to reach 100 degree Celsius, which means that the counting of time for these two balls is completely different. So you can see that I'm actually making sense here. I'm not trying to um debunk anything. I'm making sense here. If you check it now, you can see that time is different in two different environments. The only reason why we are just considering time as something that is only relative to the observer is time is yes relative to the observer, but time is more than that. The reason why we are not seeing time as time supposed to be seen is because we are not considering the fact that there is another arrangement. There are other arrangements in the universe. We have other solar systems that their structure, their ecology is totally different from the ecology of our universe. Where the ecology is different, the movement of time is completely different. So, if it takes about 2 hours for one ball to reach 100 degrees Celsius, and it takes about 1 minute for the ball on my left hand to reach 100 degrees Celsius, which means time is also relative to the environment of mass or the ecology, the the metabolism in its in its in its environment. So if I'm in universe A and universe A tends to make time move at a certain pace because of the kind of gravitational force there, then universe B tends to make time move in the speed of light to universe A to universe B. Um yeah, so in essence what I'm trying to say now we are even getting something new. What I'm trying to say now is that time is relative to the observer, but it goes deeper than that. Two universes have different times because their internal forces, the internal forces, the internal elements are not the same in metabolism. Understand what I mean? There are universes that have inverse gravity, inverse gravitational force. Instead of pulling, instead of pushing and pulling, rather it inverts that action. So where such inverse action occurs, the speed of time, the counting of time is is totally different. Now there are with these two balls, these two examples, I want you to understand that time is truly relevant to the observer. I'm expanding the theory, and time in different universes is relevant to the occupants in the universe. So if ball one is a universe and ball two is a universe, it means it essentially takes 1 minute for ball one to become heated up. It takes 2 hours for ball two to become heated up. So um the possibilities in the two universes are is completely different. The possibilities in every universe is completely different. Why am I saying this? Because I want to get to a point where we understand that we can actually move at the speed of light in the right environment. When we are in the right, there are environments where the speed of light is the normal speed. This is what I want us to understand. We are only seeing the speed of light as far as very fast because of our current habitat in the universe. In our universe, the speed of light is very fast. In other universes, the speed of light is the is is almost as slow as the motion of their stars and the motion of their planets. So the concept of relativity is so big, is so much more bigger than what